Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thanks for joining us today. Sorry, we're getting started a few minutes late. We had some audio issues we needed to walk through. So hopefully you guys can hear and see us okay, and we'll get on with the show. As usual, let us know where you're logging in from, whether you're working from home or remote. Love hearing everyone's stories. See a lot of familiar names on the attendee sheet. So looking forward to hearing from all of you. But while you're doing that, why don't we get started? For those of you who are not familiar with us, 7Signal is the leader in wireless experience monitoring. So thanks again for joining us today. We've got a great webinar for you today. The topic is going to be around multicast and broadcast and how they're handled in Wi-Fi. And there's a lot kind of packed in there. And Mike Graham is going to lead us today in this discussion. Mike hasn't been with us in what, maybe, I don't know, a month and a half, 2 months, Mike? Has it been that long?
Yeah, I think it has.
Well, it's good to have you back. So the audience is excited to hear. I think the last time we were on, we were talking about antenna concepts, and we had some audio and video issues. So hopefully that stays away. Hopefully I didn't jinx us.
Yep, almost seems to be a theme.
I know. All right, so just a couple of announcements that we'll walk through real quick. If you've been with us before, you've seen these announcements, but if you have not, CWNP has partnered with 7Signal to help us put on these webinars. So our webinars are certified by them for CE credits. So if you are interested in pursuing your certifications, all you need to do is shoot us an email and we'll send you over a certificate for attending today. We've got a product tour that we hold every Friday at noon Eastern time. We don't do any demos or product tours on these webinars. They're all specific to helping our customers, our prospects, our friends get engaged with Wi-Fi and help understand how to troubleshoot and learn more as we go. You can get archived webinars on YouTube, on our channel. We share a lot of stuff on Twitter. So if you're not a Twitter user, that's okay. We have got everything on YouTube, but faster access through Twitter. And we always give out some prizes for folks who follow us each week on Twitter as well. And I think we're going to announce some winners here from last week's trivia and last week's Twitter followers. Kelsey, who's getting merch?
So our lucky winners from last week from Twitter, we had David Rickard and Chris Ramos. And our lucky trivia winners from last week, we had Anders Nilsson, Kent Levesque, and Trey Hester. So congratulations to you all. You should be getting some merch in the mail soon. Like Don said, go ahead and follow us at 7Signal on Twitter, and we'll give away some more prizes next week.
That sounds good. So thanks for that, Kelsey. And Anders was active last week. I haven't seen him on the attendee list today, so I got to look through that. He's been a long time with us. About time he wins some merch. But I think we're going to have to incur some overseas shipping for him. So anyway, so let's move on with the show. We've got a little bit about 7Signal for those of you who haven't been here before. Just a refresher for those of you who have. But the company was started in 2007. Hit a lot of major milestones along the way. We're really proud that we're monitoring over 1 billion data points on a daily basis, over 5 million devices. We're on a whole lot of networks, over 200 customers around the world, over 30 partners around the world that help us get our customers successful. 14 patents, which means what you see from 7Signal, you are only going to see from 7Signal. GDPR compliant, relevant for our EU customers and prospects. Homologation in over 40 countries around the world. We're staying active. And we're here because no one has created that perfect access point, that perfect network, that perfect device that's going to keep all of your end users happy and keep their digital experiences satisfying. So we're here to provide that independent network device information that you're just not getting from your current vendors. We're a great complement to them. They've got fantastic information that they're providing for you, but because they don't live on the network's edge, they're not giving you that full end user visibility that we can provide. We're fully AP and device agnostic with our platform, and we have a completely outside-in approach, which I'll get into in a second. But Wi-Fi problems present themselves differently to different folks. Everything bubbles up to one of these 7 problems. So regardless if you are unable to connect or your speed is just super slow, one of these problems is behind the reason for it. And Mobileye and Sapphire Eye are the products that we use to get to the bottom of these root cause issues. Together, they find all 7 problems. And what they're doing is they're running active and passive tests on your network and on your devices for things like packet loss, latency and jitter, roaming, looking at a full spectrum analysis, packet capture, et cetera. Really unique data that you're able to gain from having the 7 signal products on your network. And really how we're different, if you're looking at a LAN traditionally, you've got some great tools installed on your network right now. So from your access point providers to Riverbed to Nianza or AppNeta or SolarWinds, you're getting some great data. But where 7 Signal comes in, from Mobileye in particular, is we live on the device, giving you data about visibility into that user experience. So any Mac, iOS, Android, Windows device. So think of your SpectraLink scanners, your Zebra scanners, your devices that are on home networks, tablets, workstations on wheels, etc. You have no visibility into those devices without 7 Signal, and we're in a really unique position there. The same goes for our Sapphire Eye sensor that lives up in the rafters with the access points, giving you visibility into the network's edge, service level quality, the RF visibility that you don't get right now. So real differentiation in that space. And more importantly, now with work from home, those awesome network tools that you have right now aren't helping you get visibility into that home network, into the Starbucks that your engineers or developers may be on right now. They're having issues. If they're in a multi-tenant apartment building, the list goes on and on. Any of those remote networks, that goes through distribution centers that are staying active. So Mobileye's real differentiation at a time of need, and probably don't need to talk to this too much since you all live this every day, our engineers on the line, but folks are struggling to support work from home employees. The numbers are going up and up. The video conferencing and other applications, strategic applications within the organization just don't work the same that they did when they were working from your state-of-the-art offices with all those great tools you have on your network. So folks are struggling with that, and we're here to help. And we're doing a give back. We do have a free trial for Mobileye to help. It's a 50-day trial for up to 50 devices. All you need to do is go to go.7signal.com/50 for 50, and we can have you up and running in just 2 days. Kelsey will drop that link into the Q&A pane, so you all have that. You don't need to go and write it down or anything. So we've got a couple of trivia questions before we get into the meat and potatoes of Mike's presentation. So I'm going to start with this first one. And it's going to stay on the topic of video conferencing. So we get a ton of questions around, roaming in particular, but also now around video conferencing and the instability of the applications and whatnot. There's a lot that goes into it. So this first question is going to go toward that topic. For those of you who have not been here before, the way we work these polls is we give prizes out to the top 3, the fastest 3 correct answers. So I'm going to launch the poll and read it, and then as I'm reading it, you all can start responding. Take your time. This first one is a multiple choose all that apply. So I'm going to go ahead and launch this first question. I'll read it out loud here. So video, and we do have to truncate it a little bit since we don't have a lot of space to write these questions out. So the first question is: video conferencing over Wi-Fi may contain what kinds of network traffic? Session initiation and teardown, data, real-time video, real-time audio, and MOH. So I see a lot of responses coming in here right now. I'm going to give it a couple more seconds here till the percentages slow down just a bit. We got about 50% of the vote in, and there's quite a number of you guys online with us today, so thanks for joining us. All right, it looks like they're slowing down here. All right, I'm going to close the poll out, folks, and share the results, and Mike's going to help us understand these results. So the correct answers are A, B, C, and D. So it looks like A, B, C, and D. All right. What do you think, Mike? What does that mean? What does this question mean? Can you help us understand? It looks like the folks did pretty good today, though.
Yeah, it does. And really, the question is I think pretty much clear on its face. It's all of those protocols or all of those types of traffic that you may see on video conferencing. You know, so obviously you're going to need that session initiation and teardown, the setup and the breakdown. So that traffic will always be there. There's also going to be some data traffic.
Yeah, I just passed through the controls while you were talking. I wanted you to have a nice distraction while you were talking.
Audio and video, obviously if it's a video conference, you're going to have both of those. And the one that's not on the list, MOH, music on hold, usually part of a voice over IP system, not so much video conferencing. So we normally don't expect music on hold on video conferences. Although really it's certainly possible that that one could be an answer as well, as I see a lot of people answered that.
Mm-hmm.
So yeah.
All right, right on. So we've got one more. We've got lots of chances for you all to win today. So let's, good job on that one. Looks like the majority of you answered that correctly. Let's see, the next one is this guy. Same deal applies, first three to answer correctly gets the prize. And this one is also a multiple choice. Connect all that apply. Let's see. All right, this next one. What types of applications would be heavily disrupted if the client device were to change IPs? So this was a timely topic again. We're constantly asked these types of questions. We get a lot of these trivia questions we pull from questions we're getting from either customers or prospects on a daily, weekly basis. So let's see. Starting to slow down a little bit. Telnet, SIP, HHS, and HTTP are the options. All right, let's close this poll out and see how these folks did this time. So the correct answer, according to CWNP, is A, B, C, E. So A, B, C, E. So FTP, SSH, SIP, and Telnet. So a little background here, Mike. Can you help us?
Yep. All of these are very much session-based, except for HTTP, which is very transactional. It's a you know, go get this, here it is. So interruptions to that would not be majorly disruptive. But all of the others establish long, persistent TCP, or in the case of SIP, it could be either TCP or UDP, but long persistent IP sessions. So if you change an IP, it's definitely going to break those.
Right on. All right. Why don't I pull this slide down, this poll down, and we'll go ahead and get started with your slides. And for those of you who have not met you before, Mike, would love to hear a little bit more about you.
Sure. I have been with 7 Signal about, I guess it's about 6 years now. Systems engineer supporting the sales team and our customers. Been doing wireless really my whole life. First wireless LANs I installed were 450 megahertz LAN mobile band, and the client devices were about the size, shape, and weight of a brick. So we've come a long way since then. But yeah, I've been doing wireless networks of one sort or another, either Wi-Fi, wireless LAN, or some point-to-point, point-to-multipoint as well, my whole career.
Right on. We're lucky to have you, Mike.
I don't know.
All right. So you should have the controls now. I'm not seeing your screen just yet.
Okay. Let me.
And if you need me to reshare, I can certainly do that as well.
So let me see if I can find my slides here and pull those up. And here's my screen.
I've got it.
Okay. All right. So I'll give you a little bit of background here. Over the last few weeks, we've had a customer that has robotic autonomous vehicles that communicate back with their servers to find out their task over Wi-Fi wireless LAN, and they were having problems with the network. Devices kept dropping off the LAN and losing communications with their servers. So we spent some time helping them with their network, and I spent a lot of time doing packet captures and looking at the behavior of these very multicast heavy devices. And I had to go back and take a look at some of the details of exactly how multicast worked to validate that they were behaving correctly on the network. And in some cases, it turns out they were, and in other cases, we talked to the manufacturer of their bridge device and discovered that they had some firmware bugs and are sending a patch for those. So really successful, but it would have been, I think, a lot smoother if I had perhaps watched this presentation before. And this is, I'll say that this is a fairly basic presentation. I considered going into the details of multicast, and there's a number of 802.11 amendments that address multicast and address improving the performance of multicast. And if you'd like, let Don or Kelsey know, and we'll be happy to do another one of these that digs in a little bit deeper. But I think we can consider this more of a introductory, basic level. But it would have been valuable for me to have watched this before I started on it, just as a refresher. I thought I knew how everything worked, and I had a couple of misconceptions. I want to make sure that we clear those up and maybe make your lives a little bit easier. Let's start out with a little bit of definition here, and it's, what is unicast, multicast, and broadcast? And it's, just pretty much as it sounds. Unicast, we're communicating directly to a single device on the wireless LAN, one-to-one kind of communication. Multicast, we communicate to a subset of those devices, and they'll listen, those devices, on a specific multicast address for traffic destined for them. And then broadcast traffic is communications to all the devices on the wireless LAN. So whether or not they are specifically listening for that traffic, they're going to receive it. They may not process it, but it goes to all devices. So those kind of basic definitions with a little illustration. And that did not change the slide. There we go. So I want to talk a little bit about a MAC address and give a little shout out to Wikipedia here for the drawing on the left, which I lifted from Wikicommons or Wikimedia. And as I said, I want to talk a little bit about the MAC addresses because you can look at those and quite quickly identify whether a frame, and we call them frames whenever we're talking about layer 2, is a multicast packet or a unicast packet, and that is the last bit of the first octet of the MAC address. If that bit is odd, and we can look here, and of course these are hex, so odd numbers include BD and F are the odd hexadecimal numbers, as well as our more traditional 1, 3, 5, 7, and 9 in decimal. But if that digit is odd, you know immediately that it is a multicast address. And I have a couple of examples here that are common. IPv4 multicast, which is certainly most of the multicasts on most networks, and the multicast that I was dealing with on my recent project always begin with 01005E and then 0 through 7. And you can see that second digit is odd, so we know it's a multicast address. And the rest of it, you should, if you do a lot of packet analysis, you should probably recognize that that's IPv4 multicast, although tools like Wireshark will tag that for you. Another example, IPv6 multicast. Don't really see a lot of it in packet captures, but everybody assures us that IPv6 is going to be really widespread any day now. But those multicasts begin with 3333, and once again you'll notice that second digit is odd, so we can immediately tell it's a multicast packet even if we don't recognize that protocol. And it's sort of a special example. Broadcast are all Fs, all the bits are set, and it still kind of conforms to the odd being multicast or broadcast, and that F is an odd number. So you can think of broadcast as sort of a special case of multicast. I think that I hope that's kind of helpful for you to be able to just look at that second digit and its odd or evenness to determine whether or not it's a multicast or a unicast. And why? All right. I'm afraid I have a little bit of text on these, but wanted to do a little compare and contrast of how acknowledgements responses to a packet work on Ethernet and Wi-Fi wireless LANs. On Ethernet, there are no acknowledgements at layer 2. Ethernet trusts basically that frames reach their destination and leaves any acknowledgement or reliability insurance to higher level protocols. So TCP, of course, has got those acknowledgements and retries built into it, or you can implement a protocol over UDP or neither and implement your own retries. Of course, those do happen at a higher level. They're going to involve more processing than doing those acknowledgements at layer 2. But as I say, Ethernet assumes that the frames are going to get where they're going for the most part. Wireless LANs, a little bit different because they are less reliable. They are acknowledged on layer 2. So for a Wi-Fi frame, the transmitting station will send it. When the receiving station receives it, the next thing that's going to happen on that network is it's going to send an acknowledgement. Slight variation on that for block acknowledgements, but I've got a slide on that coming up. Multicast and broadcast, they're not acknowledged at all. And I thought it would be interesting to throw in a little bit on the why and the historics on this. And it's, as I said, it's all about the reliability of the medium. And on Ethernet, if we think way back and ignore kind of Xerox's 1 megabit pre-Ethernet protocol, really the earliest PHYs that were widely implemented were 10 base 5 over RG8 thick coax and 10 base 2 over thin coax. Those networks easily detected collisions. All they had to do was monitor the voltage on that coax cable, and if two stations tried to transmit at the same time, everybody could detect a collision, and those frames could be immediately retransmitted at layer 2. You didn't have to involve any of the higher levels of the stack. So that worked really well. Collisions were really about the only thing that routinely caused a transmission failure on those coax networks. And of course, today's Ethernet is even better. And those collisions were really expected as part of the protocol. But since they were detectable and you could retransmit right there on the NIC, very fast turnaround, not a big deal. Wireless LANs are a big problem because there's really no good way to detect a collision. If two stations light up at the same time and they step on each other, all the receiver knows is it didn't receive the packet. It doesn't know if it's a collision or if it was something else. And it doesn't matter. It didn't get that. It did not get that detection, and therefore it's not going to act the packet. It's not going to acknowledge it received it, and the transmitting station can turn around and retrans that immediately, and once again without having to involve the higher levels on the stack. And since retransmits, failures of packets to get through on wireless LANs can be really high. I mean, compared to Ethernet, where it's a fraction of a percent, we often see wireless LANs with 30% of the frames being retransmitted. And if you had to involve higher levels of the stack, if you had to bring the host processor online to handle that at upper layers, it would be very resource intensive, especially for battery powered devices that would have to wake up and handle that. So that's why we do acknowledgements on wireless and we don't do them on Ethernet for Unicast packets or for anything else. Whoops. I think I think I already said this, but for wireless LANs, Unicast packets are always acknowledged, and that can either be a frame and an acknowledgement, a frame and an acknowledgement, et cetera, or 802.11e, which is quality of service related enhancements, introduced block acts as part of the multimedia performance improvement, which lets a transmitter set up a session, here I'm going to send you several frames, and then it can roll off a number of frames and request the receiving system acknowledge those then. Either way, those Unicast frames are always acknowledged, and the block act really is just a performance improver. It lets the transmitting system roll off multiple frames in a burst and then acknowledge all of them. And as I say, that was part of 802.11e that got rolled into 802.11n. A couple words about the data path, and this is something that I didn't realize was a misconception until I started doing a little bit of research to put this presentation together, and I found a lot of questions online that indicated people were confused about this, and what their thought was that for multicast and broadcast, that was a client-to-client traffic, that when a station, a client sent a multicast packet, that the stations around it simply heard that packet. And that is not at all how it works. Over on the left, we see what what really happens in that when a station wants to transmit a multicast packet, it sends it up to the access point, and then the access point will forward that to other clients on the wireless LAN. And I'm not showing it here, but also potentially it will forward that packet onto the wired network so that it can be passed along to other clients on other access points or other parts of the network. A little bit more about MAC addresses. I know this maybe seems like an odd order, but I think it's the right one. For Ethernet, we're really used to seeing two MAC addresses in a frame. The destination, where that frame is headed, and it'll either be a router if it's off of the subnet, or it'll be the MAC address of the client that it's headed to, and the source address, the MAC address of the sender of the frame. Wi-Fi for data frames adds a couple more fields there, and you may not be aware of them because tools like Wireshark generally by default do not show them, but they are the receiver address, which is the immediate recipient of that frame, so potentially the access point, and the transmitter, which is the MAC address of the device that is immediately transmitting that frame. So source and destination are the ultimate source and destination, and the receiver and transmitter are essentially relays. I did a little bit with some real addresses in here, showing that data path and showing what's in those fields. So we have the same diagram. Our device on the left with a MAC address here, 396E, is going to send a multicast packet to all of these other stations on the LAN, and it's going to use it, it's going to send it using this access point A950 above. So when it transmits, the destination address is that multicast address. It's that second digit odd, so we know it's a multicast address. But that is not the receiver. The receiver is actually the access point. And then, of course, the source address and the transmitter address are both the same. They're the address of that station. The access point is then going to take that packet and retransmit it, at least to the stations, maybe on the wire as well, but it's going to change those addresses. The destination address, it's still that multicast address, but the receiver has changed, and it's now also that multicast address. So any station that's listening is going to receive that. And then we've got the source and the transmitter address, and you can see the source address is still the same. It's the address of the station that originally transmitted that packet, but the transmitter address is now the access point, since it's the one that actually transmitted the frame. And as I say, this actually tripped me up a little bit. You know, Wireshark wasn't showing it. I didn't think to look for it, and I did a little bit of head scratching about why these frames were not, or the acknowledgements and also the data rates. I think that's my next slide here. Yeah, and this is, I'm sorry, but it's another text frame here. A little bit of contrast between unicast frames and our multicast and our broadcast. Unicast frames are always going to be transmitted at the highest data rate in common between the transmitter and the receiver that can be achieved on the current signal conditions, with the current environment. And that is a negotiation that happens in real time, and really it's controlled by the transmitter. The transmitter is going to send a packet or a frame at the data rate that it chooses, and it's usually going to start at the highest data rates they have in common. If it doesn't get an ACK back, it's going to try again, possibly at the same data rate, possibly at a lower data rate, and it's going to look for that ACK again, and it's going to keep retrying at progressively lower and lower data rates until it either gives up or it gets an ACK back. And that algorithm is very much under control of the access point vendor in the case of an access point, or the driver authors in the case of a client, and they can vary quite dramatically in that algorithm. And we can see that really well in our Sapphire product, where we do monitor the over-the-air data rates that the clients and the access points are using, and we can see that different manufacturers make different trade-offs between how aggressively they want to try to use higher data rates versus the amount of retransmits that they have to have. And that's kind of everybody's secret sauce, and that definitely changes between firmware versions and driver versions. Multicast and broadcast frames, they've got a couple of issues that Unicast frames don't have. And that is that all stations, and that includes the very least capable station on the network, has to be capable of receiving those frames. So that sets a constraint on it. And then we have another constraint, which is that that frame is not going to be retransmitted. So we need to maximize the chance that all stations that need to hear that frame can receive it. So we do that by transmitting at the lowest basic rate, the lowest mandatory rate. And transmitting it at a mandatory rate solves number one, because we know that the station is capable of supporting that rate because it is marked as a mandatory or basic rate to join the network. So if you have 802.11b rates turned off on your network, you don't have to worry about a B client receiving the frame because it's not on your network. The solution to maximizing the chance that all the stations are going to receive that is to use the lowest basic rate. Those lower rates are much less subject to interference, they're more easily decoded, and they have the highest chance of being received by the receiving station. And I know this was a bit of a short webinar, but I thought that it would have been helpful for me, so I hope it's helpful for you. Don, I'm going to turn it back over to you at this point.
All righty. Thanks, Mike. Great job. I'm going to turn it over to some questions here in a minute, but I've got some more trivia questions for you all today. So I'm going to go back to my trivia swag screen here, and we're going to see how you guys do. We've got two more questions here, and I was reading through the chat and noticed that some of you were only able to add one answer to that last one, which probably means all of you were only able to do it. So I apologize that we didn't put a multi-answer in there, but fear not, we'll still pick three winners. So we'll just do the first three that picked one correct answer. So with that said, we'll go to trivia question number 3 of the day. And again, I'm gonna read this, give you guys time to answer, then give you all the results. So let's launch the poll up. So the question is, as a general design practice, what minimum PHY rate is recommended to ensure voice over wireless LAN quality? 11, 18, 24, 36, 54 are the options. Again, only one correct answer this time. So we'll see how everybody does. Alrighty, let's close out the poll and share the results here. Mike, how did everybody do?
I think everybody did really well. I was guessing for 24, and I think that's the right answer.
That's correct.
All the others are not bad. I think 24 is actually pretty modest. If you look at the CWNP materials, I think it says something about 54 is impossible to achieve on a routine basis or something. And I'm gonna take a little bit of an exception to that, just because I've spent a lot of time looking at data rates that are actually used on wireless LANs. As I said, it's something that the software monitors, and it's a metric that I look at a lot. And frankly, in our customers with our best performing wireless LANs that are really designed around voice, we very rarely see data rates below the low 100 megabit range, as long as the clients are capable, and assuming 40 megahertz wide channels. So I think that 24 is a fine data rate for voice, but try for better rates. It's certainly possible to routinely achieve much higher data rates than 54. Not every frame, of course, but most clients, most of the time, in a well-designed network, we see the vast majority of traffic at much higher data rates than that. So.
Right on. All right, last question, and then we're going to hand it over to Kelsey for the Q&A, and she'll also help us catch up on the shout-outs for everybody. Got a lot of folks telling us where they're logging in from and whether or not they're working from home or not. So last question, last opportunity to win some swag today. What design considerations should be considered about when using 802.11-based multicast frames for real-time applications? A, multicast frames are not acknowledged. B, multicast frames are sent using the lowest basic rates in BSS, C, multicast frames are sent using the highest basic rate in BSS. And D, delivery assurances for clients with power saving enabled. And the last one, wired network co-decency to enable multicast applications. So there are 4 correct answers on this one. So let's see how folks are doing. I see the answers are still coming through. So Mike, for this one, I'll read the...
They better get right, right?
Yeah. Please get some of these right.
And
okay.
Actually, I think Dave, one of our other engineers, did a power save webinar in the last couple of weeks as well. So our frequent flyers should get that one right as well.
Absolutely. All right. So let me read the answer. The correct answers real quick are A, B, D, and E. So a little color here, Mike, and then we'll hand it over to Kelsey for some questions.
I think
if any.
I think that we really covered those, and kind of shame on you guys that said the highest basic rate.
All right. Well, thanks everyone for answering those. Really good job today. Kelsey, what do we have in the Q&A pane?
Yeah, thanks, Don. So first, let's catch up on a few shout outs that we have from people tuning in. We have John from Canterbury, England. Thanks for joining us. We have one of our regulars, Olivier, tuning in from Vancouver. Let's see here. We have John tuning in from Milford. And we have Gustavo tuning in from Portugal. Thank you guys for joining us today. All right, so keep putting your questions in the Q&A panel. We'll start with this first one here. We have from Jim to Mike. What are your thoughts on the vendor proprietary features that convert multicast frames to unicast at the AP?
Yeah, that's actually something that I considered including in this presentation. There's a number of kind of multicast enhancements that I think maybe we'll cycle back around and do another presentation on. But I'm basically in favor of them, especially with these, as the network performance gets faster and faster, and we're perhaps transmitting those multicast frames at 6 or 12 megabits on a network that's capable of 600 or 800 or even gigabit level performance in theory. It gets more and more important, I think, to be able to transmit those multicast frames at the higher data rates, and those features that allow you to convert them to unicast are certainly going to help with that. So I'm in favor.
Awesome. Well, thank you, Mike. We have another question here from Deepak, and his question is, how is multicast handled in 802.11ac with MU-MIMO?
Before I answer that, I'm going to go back and do a little bit of research on that one, because I am not sure what the answer is whenever you consider multi-user. Sorry.
Deepak gets a prize for stumping Mike.
Yeah. I think that's a Dave or a Jim question there.
And while I'm giving out prizes, the funniest comment in here, Mike D was telling us where he's logging in from. He says he's in Michigan, and he said directly after that it says with the worst governor in America. that almost made me laugh out loud. That was pretty funny, Mike. We might have some folks who disagree with you in the comments.
All right. We had Jim who just touched on that last question that we had here. His comment was MUMIMO has no effect on multicast handling, just to confirm. All right. And I think that was our last question for the day. If you guys have any other questions, feel free to reach out to us or Don, and we can answer them via email.
And if I could add, let Don or Kelsey know if you would like us to do a deeper multicast, because I specifically skipped over a lot of things like those conversions of multicast to unicast. Try to keep this pretty basic, but if we want to go deeper on it, let us know and we'll do another webinar.
Yeah, we're already getting a bunch of yeses in there, Mike. So we'll schedule this a couple weeks out, give you some time to pull some slides together and some more trivia questions.
Awesome.
All right, everybody, thanks a lot for joining us today. Happy rest of the Wednesday to you all. For those of you logging in far away, hopefully the day is over for you and you can wrap it up. We'll see you all next week. Have a great rest of the week. Thanks, everybody. Thanks, Mike.
Goodbye.